Hello guys, welcome back. So in this video we are going to learn about how to create the spectral reflectance curve in Google Earth Engine. So the spectral reflectance curve is a graphical representation of the spectral response of an object over the different wavelength of electromagnetic spectrum. Okay, so the reflectance characteristic of the surface features are represented using these curves. Okay, so we can see here, so this red is the build-up area. So whenever we go here, so the reflectance value is 0.149 for the wavelength 482. Okay, similarly, so the reflectance value is 0.212 for wavelength 865. So this is the spectral reflectance of the build-up area. Similarly there are also for the barren area, and like this way. So this curve gives an insight into the spectral characteristic of different objects, and hence it is used in the selection of particular wavelength band for remote sensing data acquisition. Okay, so here you can, so the graph is drawn between the various wavelength of electromagnetic spectrum on the x-axis. Okay, and the amount of reflectance that is in the percentage or some kind of in value that is recorded by the remote sensing system on the y-axis. Okay, so without any delay, let's start coding. So let's go to the new script. Okay, so let's go to the new script, and for this at first we're gonna select the region of interest. Okay, let me select the region of interest of my area. So this is my area. Yeah, this is my area. Let me select a minimum. Okay, this polygon. So let's name it as a region of interest ROI, and we need the Landsat 8 data. Okay, let's see what's here in the Landsat 8 data. Okay, we need the TOA reflectance, that is top of the atmosphere reflectance. Let's import it. Okay, so let me rename it as a YALET. Okay, so the next we are going to do is that applying some filter. So we're gonna create a variable image, and we're gonna apply some of the filters. So at first we're gonna apply the filter bounce. So we're gonna get the Landsat 8 imagery in this certain area or action that is inside the region of interest, or that contains the region of interest. Okay, and next we're gonna filter the metadata. Okay, we're gonna use the cloud cover, and we're gonna use the less than the 10%. Okay, and the next one we're gonna filter is the date. So we're gonna use the for the year 2022 of the whole year. So we're gonna use the date from 2022 12/31. Okay, and then the next filter we are going to apply is that okay, we're going to use the median. So why we are going to use median is that because the result we get up to here is the feature collection. So there are the many Landsat imageries of the different time. So basically in this time also there are the many different Landsat imageries. So we're gonna use the median for getting the single Landsat imageries. Okay, let's see what's here in the image. Let's run. Okay, there are 17 bands. Okay, yeah, so it's okay, and let's add it into the map. So we're going to use the add layer, map.add layer, and we're going to use image. Okay, let's run. Okay, the cover is very big, no problem. Okay, the layer is loaded, but it's not true color image, so let me change it into the true color image. So we're going to use the band 4 as R and band 3 as G and band 2 as blue. So we're going to use the stage values to sigma, and let's apply. Yeah, it's better now, and let me import it. Okay, so I'm going to define the image visual parameter here, so that I don't have to set the parameter every time. So here, okay, so let me run it again, and we don't need to define the visual parameter again. Okay, so now we can see the true color image, and the best thing is that we can see the true color image. Okay, so here are some of the pictures. So this is the residential area, okay, and some of here are the agricultural area. So what we're going to do is that we're going to create a new layer, and we're going to add the point picture here, 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 this side. So at least make some points, about 10 points for this tutorial. Okay, at least. So this is a build up area, so we're going to change it to feature, and we're going to use the property. So we're going to use the build up, and this is the build up name. Okay, similarly let's create a new layer, and this is going to be the forest. 3 4 5 6 7 8 9 10 11. Okay, so this is going to be the forest. Okay, forest. Okay, this is going to be feature, and we're going to add label, and that is the forest. Okay, so similarly let's add some other. Okay, so this place look like the agricultural land, so let me create a new layer. Okay, this one also, this one also, this one also, this one. Okay, this one also look like. Okay, yeah, this much. Okay, let's do same agriculture, and let's set it as a picture, and let's set the property label, and let's set it as a agriculture. Okay, now let's do the barren land. Okay, we have seen here many barren land. Okay, so these are the barren land we can see here. Okay, so let's do the same. Okay, and let's add some water bodies here. So basically it should be on this side. Can you see? No, not properly. Okay, most probably you can see on this side. Yeah, this is the water. So let's add some. Okay, 1 2 3 4 5. Okay, let's set only this data. Okay, this is the river. Okay, river. So we have added the different point file. So what now we are going to do is plotting the spectral response curve. So I have written as per commenting out, so this is a mistake because I am learning and making videos on the R, so I got mistake over here using the hash sign instead of the double slash. So I'm going to publish the tutorial of R programming and basically the geospatial analysis with R in some days. So if you want the access to that course in Udemy, you can comment down, you'll get the code for it. Okay, so we are going to plot the spectral response curve or the curve. Okay, so for this we're gonna do that, we're gonna get the subset of the bands available. So for this we're gonna do is that image dot select, so we're gonna select the band. Okay, that is from B, okay, capital B 2 to 7. Okay, yeah. So next we're gonna define the samples. So that is the what we have taken the sample from the image, blue color image. Okay, that is the forest built up agriculture and barren and river. Okay, doesn't matter which order we write. Okay, so this is the subsetting and getting the sample. So now we are going to create the, again has for commenting that mistake. Okay, we are going to create the line chart. Okay, so for this what we're going to do is that we are going to create a variable chart1 and we're going to use the UI dot chart dot image regions. So basically what it does that it's gonna create the chart. Okay, it's gonna create the chart. Okay, so we're gonna use the subset, that is the bands, and we're gonna use the samples, and we're gonna use the reducer dot mean. So it's gonna give the mean of the all the mean of all the point data, and we're going to use the 10 and we're going to use the label. So label is basically what we have created on here. So this is the label. Okay, yeah. Okay, now we are going to set the chart type into line chart. Okay, so let's see. Okay, there is one. Okay, now let's hope it is right. Okay, let's see, let's run the code. Okay, sorry, I haven't printed the chart here. We have to print the chart. Print chart 1. Okay, now let's run. So now our chart is being generated. Yeah, we can see the chart. Okay, let's see the full screen. So this is the band name here, and this is a band mean. Okay, so image band is these values, and this is the forest, and these are the reflectance. Okay, so let's do some customization. So for this we're gonna create a plot option. So we're gonna create the plot options, and we're gonna use title. Okay, Landsat it surface reflectance curve. Okay, the spectral reflectance curve, anything you want, that is title. Okay, so the next thing you are going to do is that we are going to set the title of the horizontal axis. Okay, and vertical axis. We'll set the name as reflectance, so that value is basically the reflectance. And the next one, we're gonna set the line width to 2, and we're gonna set the point size to 4. Okay, and we're gonna create the curve type. Okay, curve type, that is based on the function. Okay, for which the series is like this. Okay, 0, and we're going to define the color. Okay, that is the green. So it is for the forest. So 0 means that this value, and 1 this build up, 2 agriculture, like this way. Okay, so don't get confused. Okay, here should be a comma, and similarly let me copy it for more 4 times, and this value is the 1 2 3 4, and this value is red for build up, and lime for agriculture. This color code for barren, and blue for river. Okay, blue for river. So we have created some of the plot options. So now let's create a wave. Okay, so this is basically the value of the wavelengths: 482, 562, 655, 865, 1609, 2201. Okay, okay, so we have done this. We have to change somewhere here, so we're gonna give here the value of the wavelengths, so that will set the values of these values in this x-axis, and we're gonna set the set options like this. Okay, now let's run and let's see the output, how the output will come. Okay, you can see the output now. Let's see in the bigger screen. So these are the value of the wavelength, and so these are the curves, and these are the value of the reflectance. So this we got the spectral reflectance curve in Google Earth Engine. So this much for this video. Maybe we'll meet on the next video. Till then, have a good time.